Hi, my name is Teresa Jurgens, and welcome to this reading of the Innovation Process book. We are reading along in the Innovation Process book available from Amazon. You can scan the QR code on the screen to get your copy. I recommend the paperback copy because there are so many figures, graphs, and tables and tools in this book that I think you're going to be more satisfied with the paperback copy than the Kindle version, but it is available in Kindle as well. We have just wrapped up part 1, which talks about waterfall NPD processes in episodes 2 through 10. So check out the YouTube channel for that information. And we are starting now on part 2, Agile NPD processes. Each part of the book covering waterfall, Agile, WAGILE, and lean new product development has the same format where the first chapter that is in each part covers an overview of the process. Therefore, here in episode 11, we're covering chapter 7, Agile NPD Process Overview. So, ready to get started? We'll just go ahead and dive right in. In 2001, a group of software engineers met to formalize a project management philosophy that they hoped would facilitate and address issues with traditional waterfall project management. They called this document the Agile Manifesto and outlined several arenas to improve product development for IT. A key focus was to deliver value to customers while assuming that change is normal during project execution. To speed development and implementation for software products, the Agile philosophy was generated to contrast traditional innovation with a new approach to improve value delivery to customers. As such, figure 7-1 shown here emphasizes elements on the left more than those on the right. Communication, experimentation, customers, and adaptability are agile practices to increase speed to market. To address some of the previously identified issues with waterfall project management, see the episode on Chapter 6, number 10 episode, especially for software product development, individuals and interactions are emphasized more than process and tools. One study estimates that 40 to 50% of a project manager's time is spent on activities that do not directly deliver customer value. Managing the bureaucracy of a process and blindly following processes costs the team efficiency in designing and developing new products. Communication across functional boundaries is necessary to effectively deliver customer value. Delivery of product is also emphasized over documentation in Agile project management. One concept that has emerged from adoption of Agile and Lean practices over the past couple of decades is the minimal viable product, or MVP. MVPs are the result of experimentation in an adaptive project in which the fewest features are released in a new product to validate customer needs and acceptance. Agile projects also serve and strive for continuous learning by using iterative development and techniques like retrospectives. Conceptually, failed experiments create learning opportunities for the team and will result in a better product for the customer. Next, customer collaboration is emphasized over contract negotiations, yielding an enhanced customer focus. Risk aversity often drives lengthy contract negotiations with legal clauses intended to account for every possible error, failure, or mistake caused by the customer or the producer. While it is important to ensure that customer needs are met with the product design, NPD teams deliver customer value by spending their time on technical and market development rather than envisioning worst-case scenarios. Another critical element of customer focus in Agile and hybrid project management processes is to involve the customer in as many ways as possible during product development, such as needs assessment, concept testing, and prototype evaluations. Finally, being able to respond to changing market conditions and adopting emerging technologies is a key emphasis of Agile. Again, one of the most common complaints about staged and gated NPD processes is that the project adheres to the plan more than customer needs. Adaptability means that if markets or technologies change during a product development project, the output of the innovation team should also change. Agile and hybrid project management processes for new product development, NPD, include iterative and incremental development to ensure products meet changing customer and market needs. Requirements and technical uncertainties. At a high level, selecting an appropriate NPD process hinges on understanding what the project should accomplish and how to execute the work to achieve those accomplishments. In Chapter 2, we discussed two elements framing what to do and how to do it. The upper right-hand section of Figure 2-1 illustrates projects that are inherently risky, meaning that both requirements uncertainty and technical uncertainty are high. Perhaps a purest form of Agile NPD teams typically follow the scientific method to address such inherently risky projects. In the framework of the scientific method, a hypothesis is proposed, experiments are designed and conducted, data is collected and analyzed, results verify or not the hypothesis, and the next hypothesis is tested. The hypothesis is a proposal to narrow requirements uncertainty, and the test methodology begins to reduce technical uncertainties. Agile project management systems are built on iterative and incremental learnings. Just as an R&D team will iterate to reformulate a hypothesis over time, they learn from each experiment conducted in the hope of validating the hypothesis. Most firms use R&D projects to enhance the technology portfolio within the organization. Results of R&D programs can define future technologies for the company to investigate for product solutions, yet rarely do firms leap from research to product commercialization. There are many benefits to continually testing and evaluating R&D efforts for product management. First, R&D programs help to identify long-term technologies that are later translated into specific new products or features. Second, personnel working in research often become experts in the technology and can offer insights during product development that might not otherwise be available. For example, if technologies are licensed. Next, as an NPD project progresses, in-depth analysis and testing, especially of failed products, is a frequent necessity and best conducted by the R&D lab teams with the most knowledge about the product. Finally, building knowledge and experience across multiple disciplines within the firm enhances organizational know-how and commitment to innovation. Agile project management approaches. Note that no single system, method, or process is dictated by the Agile philosophy. Instead, the fundamental principles of communication, experimentation, customer focus, and adaptability serve as guardrails to guide the unpredictable activities of product development for teams and organizations. However, there are several common industrial applications of Agile project management, with Scrum being the most widely adopted for tangible product development. Scrum is the most widely adopted Agile project management approach and can be more readily applied to tangible product development as well as software. Subsequent chapters focus on Scrum as a preferred Agile approach for new product development, so we provide only a very brief overview here. Applying the general principles of the Agile Manifesto, the Scrum team is small, perhaps 6 to 10 individuals, to drive communication and collaboration. The team works in short iterations, called sprints, to deliver incremental and complete elements of the product. A Scrum Master provides guidance for the team by removing administrative obstacles, while the customer, via a business representative, gives direct input to the work done during a sprint. A set of rituals and ceremonies dictate how projects are executed. Scrum and its terminology are now pervasive in software development, with some limited success for hardware and tangible new product development. Extreme programming, XP. Recalling that the Agile philosophy was designed specifically for software product development, extreme programming, XP, is one of the more detailed approaches in adopting the Agile philosophy. Fundamental principles of XP are paired programming and test-driven development. Iterations and incremental development are also key concepts in these methodologies. Paired programming. In paired programming, two developers sit at the same workstation to design, write, and test code. With two people working closely together, collaboration is increased, and hopefully errors are reduced by having four eyes instead of two looking at each element as it is developed. Reduced errors and mistakes are anticipated as the two developers discuss different approaches to writing code. Roles are switched between the person writing code and the observer throughout the development effort to enhance learning and quality of the end product. Test-driven development. Closely linked to paired programming is the approach of test-driven development. As shown here in Figure 7-2, test-driven development anticipates a failed test. Developers write code to pass this test and repeat the cycle as necessary until the code is robust. Coupled with paired programming, one developer will write the test and the other will write the code, with the two occasionally swapping roles. By anticipating the failure and running automated tests, XP is expected to deliver high-quality results to customers on the first release. Like many Agile project management approaches, XP uses iterations and incremental delivery to enhance the quality of software delivered to customers. Iterative development is built into the test-driven development methodology as code is developed bit by bit. Another concept commonly adopted by firms using XP is the 10-minute build, in which the software package must be tested within a 10-minute period for validation. In addition to the incremental development of the 10-minute build, user stories are developed by a customer or customer representative, and the programming pair selects items they can complete within a given time frame, typically 1 week. In this way, small pieces of code are written and tested incrementally, with each section of code validated against the entire program. Companies using XP often have both a weekly cycle, writing and testing incremental code, and a quarterly cycle with software releases. Keeping people focused on the release goals can improve the definition of done, which is one of the key issues in Agile product management. See Chapter 16. Dynamic Systems Development Method, DSDM. Although not as common today, the Dynamic Systems Development Method, DSDM, is an Agile approach for projects versus products. DSDM was designed in response to the lack of structure in rapid application development, RAD. The DSDM Consortium was founded in 1994 and renamed to the Agile Business Consortium later to emphasize Agile tools and practices more than a specific process for software and business processes. As part of the group meeting in 2001 declaring the Agile Manifesto, proponents of DSDM assume that nothing is ever delivered perfectly the first time. Yet, according to the Pareto principle, 80% of the value of a solution can be delivered with 20% of the effort needed for the full solution. Rather than shooting for 100% completion and knowing that rework will be needed, DSDM allows the Agile approach of work iterations. Thus, a team does just enough work up front to get project requirements, but accepts that business requirements will change at a detailed level throughout the project. The iron triangle. In traditional project management, the iron triangle, as in Figure 7-3 here, forces upfront planning to detail the project scope, schedule, and budget for quarterly delivery, with schedule and budget typically following the scope definition. If a project goes off track, the typical corporate response is to add resources or delay the schedule. Added resources increases the cost of the project and often results in missed deadlines as well. Frequently, a further response to delays and project miscues is to accept reductions in product quality, assuming that these times and items will be addressed later. With DSDM, the schedule, budget, and quality are fixed during the project planning phase. To deliver on time, project management and project requirements are eliminated according to a prioritized list, often using the Moscow method to establish a minimum set of features, such as the MVP. Moscow abbreviates features necessity by must have, should have, could have, won't have. In DSDM, the project schedule is fixed through time boxing and is held sacrosanct. Likewise, not every project requires the same level of quality, so the highest priority is to deliver incremental product on time. DSDM products and projects follow an iterative phased approach as follows. Pre-project. Work only on the right projects at the right time. Feasibility. Verify that the project is technically feasible and cost-effective. Foundations. Establishes business rationale and how product development and deployment will be managed. Project detail is intentionally kept at a minimum. The foundations phase is revisited if elements of deployment require significant change. Evolutionary development. The development team works iteratively and incrementally to fully define project details, creating solutions. Deployment. Subsets of the full solution or the final product outcomes are delivered according to the project schedule. Post-project. Like the post-launch review and waterfall NPD, project benefits are checked against expectations. Moscow prioritization. Because scheduled delivery takes priority in DSDM, the scope of work, such as product requirements and features, must be scaled back when timing issues arise. The Moscow method of prioritization is a preferred tool in Agile project management. It is assumed to be more effective than simplistic ranking systems such as high, medium, low, or 1, 2, 3, 4. Must-have. Features or requirements that are a part of a must-deliver subset of the project. Without these features, there would be no point in meeting the delivery deadline. Must-have features also include necessary legal and regulatory requirements. Should have. May include temporary workarounds for important but not vital features or functions. Probably causes some degree of pain to not include in the release. Could have. Differentiated from should haves by decreased impact to customers and end users. These are desirable features but less important, also called nice to haves. Won't have. Features that are not included in this time frame of project deployment. These features and functions are kept on a requirements reserve list to clarify overall scope and to prevent scope creep of the project increment. Time boxing. One of DSDM's key practices, a time box, is a fixed period of time which is concluded by issuing a project deliverable. The length of time may be fixed for all increments in the project, or the development team can adjust the length of time to accommodate the deliverable or release in front of them. Typically, time boxing intervals are 2 to 4 weeks. An integral component of time-boxed work is the daily stand-up meeting. At this short meeting, each team member indicates work completed the prior day, work planned for the current day, and any roadblocks or obstacles to complete the work. Each person spends no more than 2 minutes to update their work plans. This technique is a valuable communication tool as the team members share their work status without going into in-depth problem solving that steals time from team members not directly involved in the question at hand. The concept of time boxing has been adopted in Scrum by limiting the amount of work expected for completion during any given sprint. Other Agile project management systems. Several different Agile project management systems were gathering headwinds even before 2001. A common thread among these was to reduce administrative bureaucracy and yield autonomy to developers. Consequently, the goal was to improve speed to market and to reduce quality defects. Both crystal and feature-driven development are Agile approaches that had gathered momentum prior to the writing of the Agile Manifesto, but are not widely deployed today. Understanding the history of various project management methodologies helps to clarify different systems and tools that are useful today in Agile or hybrid NPD processes. Crystal. Developed by one of the signers of the Agile Manifesto, the Crystal methodology focuses on interactions of people and teams. First implemented at IBM in the late 1990s, Crystal includes elements of customer integration, automated testing, and incremental software delivery. It is one of the least structured approaches to Agile project management and uniquely assigns a color code for the varying size of the project teams. Project complexity is implied by team size, so Crystal offers scaling that is often not immediately apparent with other Agile methods. Crystal Clear, 1 to 6 people. Crystal Yellow, 7 to 20 people. Crystal Orange, 21 to 40 people. Crystal Red, 40 to 80 people. Crystal Maroon, 80 to 200 people. Crystal Diamond and Sapphire, very large teams. Feature-driven development. Also developed in the 1990s, feature-driven development, FDD, prioritizes features that customers want while releasing software incrementally. Closer related to systems engineering than to waterfall methods, there are 5 sequential processes within FDD. 1, develop overall model. 2, build feature list. 3, plan by feature. 4, design by feature. 5, build by feature. FDD can be scaled to projects larger than a typical XP project. Delivering full software builds in 2 to 10 days, iterations are shorter than in other Agile methods. Software Agile project management approaches. Because Agile project management emerged just in the past 2 decades, there are several approaches used by different companies, in different industries, and by different proponents. Most of these are specific to software development, such as Agile modeling, Rational and Unified Process, RUP, and Rapid Product Development, RPD. We recommend a quick internet search for these and more modern Agile methods, such as Safe and Disciplined Agile. While Agile approaches are most applicable to software product development, the customer base must be willing to adapt to frequent changes. In tangible product development, flexibility in design is important, yet manufacturing facilities are often limited by capital investment. Consumers are often less forgiving of changes in a tangible product than in software. So even though there are many different approaches and systems to implement the Agile philosophy for product development, both the type of product, software or hardware, and target market factor into decisions for the best project management process. Thus, the remaining chapters focus mainly on Scrum as a preferred approach to implementing Agile principles for new product development. Scrum is even more widely adopted for tangible products than any of the other methods described in this chapter. However, many of the tools offer insights to improve product design, especially in hybrid project management systems such as Agile product development, discussed in Part 3, and Lean new product development, discussed in Part 4. Thank you for listening to this episode 11, which gave an overview of Agile NPD processes. Again, get your copy of the Innovation Process book, scanning that QR code. Join the class starting August 12, 2025 by registering at the URL that's on the screen, and follow along with the readings by scanning the QR code in the lower right-hand corner, which gets you to the YouTube playlist where we cover every chapter of the book, and new episodes are loading weekly. Thanks, and have a wonderful afternoon.